questions on homework? Do you think we got all the homework correct? No questions. Okay.
Actually, yeah, sorry. I did have a question on, I think it was 913.
Okay.
I gotta find it.
913.
Yep. The appropriate way of writing that, how is that different from C?
Well, first it's talking about the population parameter. And remember, the population parameter is those characteristics that we wrote in the population. We don't have values for them. And there were things like mu, p, things like that. It might be p1 minus p2. The notation then is those particular symbols that we used. The part C is asking about sample, isn't it? Part C says, what is the value of the sample estimate? What is the appropriate statistical notation for this estimate? Now, I'm less concerned about the notation. I'm going to, when I have the grader do this, I'm going to have the grader kind of not pay a lot of attention to the notation part of it. I'm more worried about whether you got the idea down correctly. The population values, remember, are things that we cannot calculate because we can't get through the population. Population parameters are those characteristics that if we had everybody in the population we could calculate, but we don't, so those are the things that we're estimating about. So in the cases here, they might be something like the proportion of the population that had that particular allele would be a population parameter. Symbol for that would be P. The things that they actually give you values for can come from our samples, because the samples are the things that we've taken from the population, and we can actually measure those. We can actually do calculations. So if we actually have values for them, that says that it is a sample value. So for example, the one problem had 15 to 30 was the percentage of individuals in the population that had that particular allele. Remember that one?
Yeah.
15 to 30, what is that?
Isn't that the range? Yeah, with, competence.
It's an estimate, it's a confidence interval specifically. That confidence interval comes from the sample. The population parameter of interest is the true population proportion that have that allele. So how do we interpret that 15 to 30?
That the actual percentages fall somewhere within that range?
Okay, it's very close. What else do we have to caveat that with?
Oh, for like 90% of the time or whatever? 95?
This is probably a 95% interval, so we're 95% confident that this interval straddles the true value of that population proportion. Now if I give you nothing but that interval, from that I can calculate the value of the proportion that they got from their sample. Where should that be? Should be in the middle right here. So if it runs from 15 to 30, what's in the center? I can't do it that fast.
17.
I had somebody do it for me in the previous section, so that's why. So 22.5 is the value right in the middle, and then from either side, this 7.5 is called what?
Confidence interval or
margin of error. The width from the center to the edge of the interval is the margin of error. So the confidence interval is the center plus or minus the margin of error. Okay, so if I were to give you a confidence interval, you should be able to tell me what the estimate was and what the margin of error was, right? Later I ought to be able to pick more out of it than that, because we ought to be able to, if I tell you it's a 95%, you ought to be able to come up with a multiplier and the standard error and stuff like that as well. But not yet. This is as far as we go. So this might be a reasonable question. We did this in the 1 o'clock section. I don't have a question exactly like this on the exam, but maybe you'll have to remember that for future exams. Other questions in the homework? Okay. Let me fire this thing up. First thing we want to do is take a look at what went on Friday. Actually take a look at the outcome of this simulation, talk a little bit about sampling distribution. Remember on Friday what we did is we used SPSS to generate 25 samples of size 50 from our population of rectangles. I then asked you to get some statistics and so forth on it. What I did is I did the same thing here. I ran it off and and had Explorer give me statistics. And I'll jump right down to the histograms here. So the histogram for the sample mean, we expect these sample means to be centered at, the distribution to be centered at the true population mean. That true population mean is 6.26. You can see that it came out very close here. We know what to expect of the standard deviation. That should be 5.69 divided by the square root of 25. That actually comes out around this actual values. This is fairly close to the true standard deviation. But the shape didn't come out too well, did it? Okay. With samples of size 25, the behavior of the statistics, the mean, the standard deviation, will tend to be very good. But the shape of the actual data will tend to vary quite a bit, and so we won't get this nice bell shape in most cases. It usually takes quite a few more cases than 25 to get that nice bell-shaped curve. So, but when we looked at our samples of size 5, remember how spread out those were? They were centered somewhat at the right place, but they went all the way down nearly to 0 and went up here to around 10 or so. So we had a much wider spread of values. When we went to samples of size 25, the spread got a little bit narrower, and we can see here that for samples of size 50, the minimum down here is 5, the maximum is 8, so it's narrowed in even more yet. So it's doing exactly what we would expect. As we increase the size of our samples, the spread of the X bars that we calculate from those samples is decreasing, right? Which is exactly what intuition said, and oddly enough, that's also what the mathematics says, even though we haven't gotten to that point yet. Okay? So these things are acting like we would expect them to. It says that when we get into this, we'll have a better idea of exactly what to expect of these kinds of statistics, and from that be able to make proper inferences about the population. Anybody realize what I was doing with this Z? Z was calculated as the X bar from your sample minus 6.26 divided by 5.69 over the square root of 25. Okay? That's very similar to the test statistics that we're going to be using eventually in doing our hypothesis tests. All I did is I standardized the X bar values so that they should be centered at 0 and so that they should have a standard deviation of exactly 1. Now the shape doesn't come out like we'd like it to, but the standard deviation comes out at 1.045. The mean came out at minus 0.02. So that says that I've got pretty close to what I was looking for. Okay. So it's again acting like I would expect. And these are going to be the kinds of things that we're going to base our confidence intervals and our hypothesis tests on as we get into the later sections.
Are we going to need to know that for the exam, what you did, like the calculation and
Nope.
everything? Okay.
We'll go over that in a second.
Okay.
The last thing I want to look at is I took all of the lower and upper bounds that I calculated and plotted them. So these are all my upper bounds. These are my lower bounds. This is 6.26. This is the true mean. This says that every single one of my confidence intervals straddled the true mean. Now, probabilities are that this is a 95% confidence interval. I should expect roughly 5% to miss. So out of 25, I might expect 1 to miss on average, but I didn't get any missed. I got one that came close here. This one, the lower bound is actually above 6. So this came very close to missing. Did you guys get a chance to take a look at yours and see if you found any that missed?